Hi, my name is Mel and I'm a cybersecurity student just about to undertake a diploma of cybersecurity. I've done a Cert 4 in cybersecurity, a Cert 3 in IT. I've also done studies way back in the past in RMIT. I have worked in the field as a help desk officer, computer technician, and this stuff is to help other students and also help people generally. Okay, so the following presentation hopefully offers a clear introduction to the fundamental concepts of computer networking, focusing on the OSI and TCP/IP models. Explore structure, purpose, and practical applications of these models to help beginners grasp how data travels across networks. We will cover networking fundamentals, dive into the OSI model and its 7 layers, explore the TCP/IP model and its 4 layers, compare both models, provide practical examples, discuss key differences, and explain why understanding these models is essential. Understanding basic networking concepts is vital for grasping how computers communicate. The following section introduces what a computer network is, the purpose of the network models, and essential terms like protocols, data, and communication. A computer network is a collection of interconnected devices that communicate to share resources and information. Look, honestly, the internet is just one really big network or a bunch of computer networks joined together, if you want to think of it that way. Networks enable data exchange between computers, smartphones, tablets, servers, and other devices. And there are many, many devices, Internet of Things devices, you name it, okay? Network models provide a standardized framework to design, understand, and troubleshoot networks. They help break down complex communication processes to manageable layers for easier development and maintenance. Protocols are the rules governing data exchange between devices. Okay, so that's what protocols are. You'll hear the term protocols a lot, and it's basically just the rules governing how data is exchanged or how data works across a network. Data refers to the information being transmitted, and communication is the process of the data or the information going across a network. Okay. The OSI model is a conceptual framework that standardizes the functions of a network into 7 distinct layers. It helps in understanding how data moves from one device across a network. Developed by ISO, the OSI model aids in designing interoperable network systems by dividing communication into 7 layers, each responsible for specific tasks. The layers are physical, data link, network, transport, session, presentation, and application. Each layer serves a unique function, from transmitting raw data to providing user services. Think of sending a letter. The application layer is writing the letter. The presentation is formatting the letter. The session is coordinating the send. Transport ensures delivery. The network routes it. The data manages local delivery. And physical is the postal service carrying it, if that helps to put it in everyday terms. Let's break down each OSI layer to understand its role in network communication using straightforward explanations. This layer, so the physical layer, deals with the physical connection between devices, including cables, switches, and the transmission of raw bit streams over a medium. Okay, so remember, bits is a single character, like it's a 1 or a 0. Okay. The data link layer is responsible for node to node. So computers can be called nodes, data transfer. This layer handles error correction, framing of data packets for reliable local communication. Okay. Network layer manages logical addressing and determines the best path for data to reach its destination across multiple networks. Transport layer ensures complete data transfer with error recovery and flow control, managing how data is segmented and reassembled. Session layer establishes, maintains, and terminates communication sessions between devices, coordinating dialogues and connections. Presentation layer translates data formats, handles encryption and compression, ensuring the data is readable and secure for the application layer. The application layer is the top layer, provides network services directly to users such as email, file transfer, and web browsing. The TCP/IP model is a practical framework used worldwide that simplifies networking into 4 layers, focusing on real-world application and protocols. Developed by the Department of Defense, TCP/IP defines a set of protocols for how data should be packetized, addressed, transmitted, routed, and received. Okay, protocols are just rules, if you remember, of how data should be processed or transmitted, all right? Unlike the OSI model's 7 layers, TCP consolidates functions into 4 layers, making it more straightforward and widely adopted for practical networking. Yeah, look, the TCP is used a lot more than the OSI, but really you should know both, but the TCP/IP is much more practical. The layers include network interface, internet, transport, and application. Each layer corresponds to specific network functions and protocols. Understanding how the more detailed OSI model's layers correspond to TCP/IP layers help clarify networking concepts and protocol alignment. For example, OSI's physical and data link layers map to TCP/IP's network interface layer, while OSI's top 3 layers combine under the TCP/IP's application layers. So the top 3 layers are session, presentation, and application, and they translate or are combined in the TCP's application layer. It's more simple to understand. Okay? Imagine TCP/IP as a simplified map of OSI's detailed routes, making it easier to follow data path from sender to receiver. TCP/IP is preferred due to its simplicity, flexibility, and alignment with the Internet's architecture, forming the backbone of modern networking. To better understand, we'll look at how everyday activities like web browsing, emailing, and phone calls relate to the OSI and TCP layers. Visiting a website involves data traveling down and up the layers. So they start from the top layer, go down, and then at the other end, they start at the bottom layer and go up. Okay, if that makes sense. From typing a URL at the application layer to physical signals transmitted across cables. An email passes through each layer, from composing the message to routing it across networks, finally reaching the recipient's device. Even phone calls use network layers by establishing sessions, managing data flow, and transmitting voice signals digitally over the internet. Understanding the differences in design layers, layer structure and adoption helps clarify why both models exist and their roles in networking, education and practice. OSI has 7 distinct layers with specific names, while TCP combines some functions into 4 broader layers, simplifying the model. OSI was developed as a theoretical model by the ISO, while TCP was created as a practical protocol suite by the US Department of Defense. TCP/IP is the foundation of the internet and widely deployed, whereas OSI serves primarily as a teaching tool and a reference model. For a solid grasp of networking models, it is crucial for troubleshooting, IT careers, cybersecurity, and even for non-technical professionals to understand modern technology. Knowing these models helps pinpoint where issues can occur within a network, making problem resolution more efficient and effective. Networking models provide essential framework which IT infrastructure and security measures are built and maintained. Understanding basic networking concepts empowers non-technical users to better communicate with IT teams and make informed decisions about technology. And this is why I'm doing this. It's also for beginners who are going into cybersecurity or networking or IT, or anyone like who works even in an IT company to understand just the basics, because you need to know how, at least when sort of like IT professionals start throwing terms around, you need to know what they're talking about. Okay, so this is a very, very basic overview. We'll go into more details and other stuff, but this is just to help non-technical people primarily, okay? So look, in conclusion, the OSI and TCP models are key to understanding how networks function. So whether you're a beginner or an aspiring IT professional, mastering these concepts lays a strong foundation for exploring the technical world. Thank you for your time.